Hi, I'm Ms. Vung. Let's have a look at application of anti-differentiation. Let's have a look at this graph. Let's talk a little bit about motion. Here we have a position time graph and the gradient goes from 0 to a little bit positive to very positive. So we know the derivative or the velocity time graph will look like that. So a little bit positive and then more and more positive. Now the gradient of this graph, we know that it's all positive, and the gradient of all this graph we know is the acceleration. So if it's all constant and positive, it will look like so. Now we also analyze, so this set of graphs, we can see that the velocity is increasing and the acceleration is constant. And we also describe this as differentiation. Today we're going to look at both ways. We're also going to look at going from the acceleration to velocity to position, or in other words, we're anti-differentiating. Now there are other graphs, for example, this position time graph, we can see that's very positive and less positive to less positive. So we start the velocity time graph really high to really low, and it is a negative gradient, so it is decelerating, or in other words, a constant negative acceleration. So this one is decreasing in velocity. Increasing velocity, decreasing velocity. What about this one? The velocity here is constant, and if the velocity is constant, the gradient of the velocity is 0, or in other words, the acceleration is 0. So on the t line, so constant velocity. Now another recap, let's have a look at all those different types of gradients in these three graphs. So here we have distance, here we have velocity and acceleration. We can see that at the start of this distance, the gradient or the slope is increasing, and therefore the velocity of that graph is also increasing. See? In this section here, we can see that it's a constant slope, so it's a gradient that is the same all along there, so the velocity will be constant, like so. In this section here, we can see that the gradient is going less and less and less, so it's decreasing in the gradient, so the velocity is also decreasing. And over here we have a split second of the gradient being 0, so we can see the velocity is 0 in that split second. And then over this side we can see that the gradient is starting to become more and more negative. So the negative gradient is giving us that section there. It becomes really negative, and then less and less and less negative. So from here, less and less negative. And here we are flat, or in other words, the gradient is 0. Let's analyze the velocity time graph this time. Here we have a positive gradient of velocity. So the velocity is increasing at a steady rate. So we can say that the acceleration is also positive. Here the gradient of the velocity is 0, so we can say that the acceleration is also 0. Here we can see the gradient of the velocity is negative, so that's why we can see the acceleration is negative. Here the gradient of the velocity is positive, and therefore the acceleration there is positive. And here the gradient is 0, so the acceleration is 0. Example 1. The velocity v meters per second of a car traveling along the highway is given by Vt equals 4t minus 2, where t is the time in seconds. If the distance traveled initially is 0, find the distance traveled after 15 seconds. So here we're going to summarize some bits because there's a lot of words. So the initial velocity is 0, so x of 0 is 0. And distance traveled after 15 seconds is what? That's what it's asking for. So we're looking for distance and we have velocity. What do? We anti-differentiate. So 4t minus 2, to anti-differentiate that, would give us the position time graph equation. So 4t becomes t to the power 1 becomes t to the power of 2 divided by 2. So it's 4 divided by 2 is 2. And then minus 2t. So 4 over 2 is just 2. So 2t squared minus 2t plus c. Don't forget your c. And notice that c is after your antiderive it. It's not in the original equation. So at x is 0, we say it's 0. We said that it's 0. It's given to us. So what how does that help us? It will give us what c is. So t is 0 and that side 0, c is 0. So now our position time equation is just that without the c. And now we have to figure out what x is when t is 15. So plugging t equals 15 is, we obtain x at 15 is 420. And don't forget to check your units, which is meters. So always draw a position time graph on your CAS. If you have the CAS, to check that that is the total distance. If your graph is going up and down, then it's probably more than that or less than that. So sketching it, we know that the distance is, we're traveling further and further and further away. So if x is 15, y gives us 420, then we can say that the distance traveled after 15 seconds is 420 meters. Example 2. A motorcycle rider uses a ramp to jump over several cars. The rider's vertical speed is given by vt equals 12 minus at, where t is the time in seconds after beginning the jump. If the vertical height is 9 meters when he's 2 seconds into the jump, what height is the rider at when he is 3 seconds into the jump? So there's a lot of information, so let's summarize that. So first of all, 9 meters when 2 seconds. So height means x, so position, because we're given v there. So be very careful when you plugging in x and y values. Make sure you identify what it belongs to. Now, and then we have what is the height when it's t is 3. So x of 3, what is it? So now that we have that, we clearly see that we have v, we want to get to x, so we find the antidifferentiation. So anti-deriving that would give us the xt, so 12 becomes 12t, and the minus 8t becomes t to the power 1 plus 1 is t squared. So dividing by 2 becomes minus 4t squared. Don't forget the plus c. Now we have a piece of information. So when t is 2, x is 9, plug that in. And that's going to help us find what c is, which is 1. You can do that slowly on your own to check. Now when c is 1, it means this line here becomes 12t minus 4t squared plus 1. Have we answered the question? No, we're looking for x of 3. So plug in 3 wherever you see t, and we obtain 1 again. So we now have answered the question. The height at 3 seconds is 1 meters. What is the maximum height reached during the jump? So maximum height happens when the velocity or the gradient of it is 0. So when vt is 0, what is x? So let that equal to 0. So we have obtained 8t equals 12, t becomes 12 over 8, which is 1.5. So now we have to look at the height. So the height at that time, x at 1.5, we obtained x is 10. So the maximum height is 10 meters, reached at 1.5 seconds. Example 3. An object starts at rest 3 meters from the origin and moves in a straight line with an acceleration of a equals 6t plus 8. Find its position and velocity at any time t seconds. So the position, so x, we have a, now we have to find x. How do you do that? We know how to go from a to v, and we also have to find v, and we know how to go from v to x. We're anti-differentiating twice. So first we have a, anti-differentiate, we'll get v. So anti-differentiate that, we have 6t becomes 6t squared over 2, or 3t squared. 8 becomes 8t, and don't forget the plus c. Now we also know that it starts at rest. So at t equals 0, the velocity is 0. Starts at rest. So starts means t0, rest means v0. So we can plug that in. So this is equal to v, so it's 0, and t is 0, so c is also 0. So now velocity equation would be 3t squared plus 8t, because we know c is 0. Now we have to find the position. Excuse me. So anti-deriving that will get us the position. So anti-derive that, we have 3t squared becomes t to the power of, adding 1 is cubed, divided by 3. 3 by 3 is just 1, so t cubed. Then the 8t, add 1 to the power becomes 8t squared, divided by the 2 becomes 4t squared. And don't forget the plus c. I say that a lot, but trust me, it's really easy to forget. So now we have that as our position. We also see that it starts at rest 3 meters from the origin. So starts means t is 0, 3 meters from the origin means x is 3. So we can plug that in. 3 equals 0 plus c, c is 3. So the equation for the position is x of t equals t cubed plus 4t squared plus the 3. Now we have the velocity and we have the position. Example 4. The velocity of a toy train starting from 1 meter to the right of the origin is given by Vt equals 6 minus 2t, where t is in seconds and v is in meters per second for t is between 0 and 5. When does it stop? So stop means the velocity is 0. Now we have a bit of information here. It starts at 1 meter to the right. So in other words, x is 1 at time equals 0. Now when does it stop? When is v equals to 0? So we have the equation here. We let that equal to 0. And we notice that bring the 2t over, divided by 2, we have time is 3 seconds. So the train stops after 3 seconds. Part B. What is the displacement at any time t? So this time we're looking for x. So what is x of t? So we antidifferentiate the v to get the x. So we do that by 6 becomes 6t, and minus 2t becomes minus 2t squared over 2, or minus t squared. And don't forget the plus c. Now we know that x of 0 is 1, so we can plug that in, and we obtain c is 1. So xt, our equation now becomes 6t squared minus t squared, 6t minus t squared plus 1. Part C, how far is it from the starting point when t equals 5? So is it asking for velocity or position? How far? That is position. So we have to use that equation and we have to plug in t equals 5. So plugging in t equals 5 into the equation, we have x of 5 is 6. So after 5 seconds, the train is 6 meters to the right of the origin. Part D, where is the train when it stops? What does stop mean? It means the velocity is 0. When we figure that out at t equals 3, it's asking where. What does where mean? Velocity or position? Displacement. Position. So where means that equation over there. So at when it stops, so t is 3, what is x? So we plug in the t is 3 and we obtain 10. So the train stops 10 meters to the right of the origin. So what has the train done so far? It has traveled between 0 and 5 seconds. It stopped at t equals 3 seconds, 10 meters to the right of the origin. And then it kept going, and at 5 seconds, it is 6 meters to the right of the origin. Part E, how far does it travel in the first 5 seconds? So let's recap that one more time. So it starts 1 meters to the right of the origin. And then at 3 seconds, we see that it's 10 meters to the right. And then at 5 seconds, we can see that it is 6 meters to the right of the origin. So between the first 3 seconds, it has traveled 9 meters. And then from 10 meters back to 6 meters, it has traveled to the left and it's traveled another 4 meters. So how much has it traveled in those 5 seconds? It has traveled 9 plus 4, 13 meters. So it's important that you visualize what is happening. You can do a timeline of the x with the t, see t0, t3, t5, and then you can see what is happening. So the total distance is 13 meters. Thank you for watching, and I'll see you next time. Bye!